Okay, now I'm going to talk about cameras. Um, if you click on the main camera in your hierarchy view, you see that these guidelines here show what the camera sees, which is what's going to be rendered into the game view down here. So I'm going to rotate this camera around so he's pointed at my lerps character. Get him a little bit closer. There we go. Okay. Now, with the camera selected in the hierarchy view, look in the inspector. The clear flags property here tells the camera what to do with areas of 0 information. So right now, it's being filled with the skybox. If you change it to solid color, then these areas of no information in the sky are going to be set to a background color defined here. And you can set that to whatever you want. Go ahead and change this back to skybox. Now, normalized viewport rect is the bounds and position of the camera in relationship to the screen. So right now the game screen is this box right here. The origin of the camera is 0, 0, which is 0 pixels from the left and 0 pixels from the top, right here, this point. The width and the height is 1, and that means that it fills up the entire width of the game view and the entire height of the game view. If I changed width to 0.5, the camera would render only half of the game view. So I'm going to change that to 0.5 right now and hit enter. And you see that only half of the width is rendered from the origin of 0, 0 up here. You can drag the width to make it bigger or smaller, like this. Set it back to 0.5. And if you move the X and the Y here, you can actually set the origin. So if you set X to 0.5, then you can see that this camera is starting rendering at 0.50 here, and it's rendering for half of the width here. The same applies to the height. I'm going to change this back to 0, 0, 1, 1. Hit enter. Now the near clip plane is the distance from the camera at which things start to render. So if you set it very far away, then you can see in your game view that objects won't start rendering until they're 15 meters away from the camera. This is not what you want, probably, so set it to a value that makes sense for your game. I'm just going to put it back to 0.3. It's default. Far clip plane is similar, but it's the distance from the camera at which things stop rendering. So right now, nothing past 1,000 meters from the camera renders in the game view. But if you make this smaller, you'll see that. You can actually see this reflected in the scene view, where this guide gets smaller and smaller. You can see that nothing past, right now, 45 meters is getting rendered. Nothing past this point in the scene view, this point in the scene view is getting rendered in the game view. I'm going to go ahead and set that back to 1,000. Field of view is how wide or narrow an angle your camera has. So that's how much of the world, left to right and up and down, it's fitting into one frame. Again, this is going to be reflected here in the scene view as I change it. So I'm going to make it bigger. You see that your angle gets wider. Make it smaller. Your angle gets narrower. This mimics the function of a telephoto zoom lens in a camera. If you want like a a crosshairs thing, or a sniper scope or something, you can change your field of view to a low field of view, and it'll look like a zoom camera. Also, if you make it a wide field of view here, you'll see that objects along the side are curved a little bit. I'm going to change that back to the default 60. The orthographic setting tells the camera whether or not to view things in perspective. So this is just like in your scene view. If you right click here and uncheck perspective, you see that the world no longer has perspective to it. Everything is in essentially the same distance from the camera. Right click on it and check perspective again. So in the game view, if you want that to happen, you can make your camera an orthographic camera by checking this box. And I'm going to rotate my camera. Whoops. I'll change it to global rotation. And there we go. So it's a little funky right now. I guess I can zoom it in. Oh, right. Okay, so if you're in orthographic view, field of view has no relevance. Orthographic size is the setting you want to use to zoom it in or out. So now, if I zoom in to my lerps guy, move this around, you may notice it looks a bit like Diablo. That's because Diablo uses the same type of camera, an orthographic camera, from the top down. I'm going to go ahead and uncheck that. Move this back so I can see my little lerps guy. Depth here refers to the order of cameras that are being rendered. So this is, if you have more than one camera, you get to choose which camera is on top in the rendering. So I'm going to go ahead and duplicate this main camera by going Control D, or you can right click and duplicate. My second camera I will call camera 2. This camera, I'm going to change the depth to 1, which is going to put it on top. And I'm going to set the width to 0.3 and the height to 0.3. I'm going to move the X over here and move the Y. So now you see that I have two different views here in the game view. One's this tiny little window represented by camera 2, and one is the bigger window represented by main camera. If you click on camera 2 and you modify it, you can see that this little picture-in-picture is changing and updating live. If you change the depth of this camera 2 to be less than the main camera, so -3, then now it's behind. It's being rendered behind the main camera. But I'm going to leave it back at 1. Now the culling mask here lets you select which layers in the game you're going to have your camera view. So right now your camera is rendering all the layers in the game. But remember, we had created this custom ignore layer previously. So I'm going to duplicate my lerps by going Control D, or right click duplicate. The second lerps in my scene view I will move off to the side. Now this second lerps I'm going to add to the layer custom ignore. Yes, change the children. So for my main camera here, the culling mask currently is set to every layer. I'm going to uncheck the custom ignore layer. Now this camera is no longer rendering that lerps. That's part of that layer. The other camera, however, still is. So if you move this camera closer, you see in the picture-in-picture, make it a little bit bigger. The picture-in-picture still renders that both lerpses, even though the main one, which has this layer unchecked, does not. Another cool thing you can do with cameras, there are some scripts that ship with Unity. They're located in component scripts up here. Actually, component camera control. One is smooth look at. So I'm going to first go in my scene view down here. I'm going to go to Game Object, Create Other, Sphere. And there's a sphere. I'm going to make it bigger, nice and big. Nice and big. Actually, it's you'll notice right now that you don't see the sphere. I think it's because this perspective view is really deceiving. So I'm going to go back to the top view, and I can see that this sphere is, oops, much farther away than I thought it was. So I'm going to move it up near my cameras, go back to perspective view, and there we go. Now I'm going to make it smaller again. Press F to zoom in. Okay, so this is a sphere. Great. You can tell actually I'll tell this little picture-in-picture camera to, going to add a component, camera control, smooth look at, and it adds this this component to the camera. Now there's an empty slot here for target. I'm going to drag sphere, the game object from the hierarchy, onto the target property. So click on camera, then drag sphere onto the target here. Now when you click play, that picture-in-picture camera should look at the sphere, which it does. If you it was a little choppy that time. I'm going to play it again. Well, it's still choppy, but you can see it actually gradually goes from its initial position to the sphere. To make the sphere controlled by physics, you just have to go to Component, Physics, Rigid Body, and a rigid body component will be added to the sphere game object. Use gravity is selected, and you hit play, and you'll watch it fall to the ground. And there it goes. It falls to the ground and actually rolls. You'll also notice in the picture-in-picture that the camera follows it no matter where it goes, even as it's moving, which is, it's really neat because it required no coding at all. The folks at Unity did it for you, and it's just a nice way to add some kind of really quick and easy camera functionality to your scene. So I'm going to click play again to stop simulating. You can also change, this is kind of a digression on some physics stuff, but in the sphere collider for the sphere, if you change the material, which is the physics material, not to be confused with texture material down here, which is how it looks, you can change that to bouncy, and then when you hit play, your sphere won't just thud when it hits the ground, it'll start bouncing. And your camera will follow it as it does all of this. You'll also notice throughout this, there's been this warning down here on the console. If you click on it, you'll get a more detailed view. It's actually not more detailed. It's pretty clear cut. It's saying there's 2 audio listeners in the scene, and you can only have one at a time. That's because main cameras have audio listener components as part of them. What that means is that all of the audio sources in the game, like ambient sound and sound effects, are going to be calculated from that position in the space. So if you have a first-person shooter, you want that first-person camera to be the audio listener. You want, when someone fires a gun from the right of you, you want to hear it to the right of you. And when they fire it from the left of you, you want to hear it to the left of you. So if you have 2 different audio listeners, for example, right now we have a picture-in-picture and a main camera, then the game engine doesn't know which one to calculate the sounds from. So I'm going to go to the picture-in-picture camera, and I'm going to uncheck the audio listener component. Now if you save it and simulate it again, this error should go away. There you go. And you can also have this set dynamically with interactivity scripting, so you could switch between one audio listener and another if you, say, had a cutscene at a different point in the game, like a different physical location, or any number of applications. The Pro version of Unity can also render cameras onto textures. So not only can you render them to this 2D flat space that is the game screen, you can put them onto some kind of projection in-game. So you could actually have a live video feed, or you could have a movie on a movie projector, or you can have a projection onto a plane to play some kind of intro logo to your game.